Alright, so in this video we're going to talk about how you can determine the moment of inertia or the second moment of area for a composite section. So for a composite section, it would be an area that's composed of simple shapes such as triangles, rectangles, or circles. So if we can find the moment of inertia or the second moment of area for each section, the total moment of inertia is equal to the sum of all the sections. So in order to do this, the first thing you're going to do is, if you have a composite area such as this, maybe we have something that looks like, alright, where we have the non highlighted section is solid, and then the circle in the middle is a hole, or there's no area through that section. So the first thing we would do is we would split this composite area into simple shapes. And let's say we defined our origin on the bottom left-hand corner of our section. Okay, so the first thing we would do is we would split this into composite shapes. So we would break this down into three parts. We'd have our triangle, we'd have our rectangle, and we would have our hole or our circle. Okay, so that's the first step. Alright, the second thing we would do is we would want to find the distance. So if we were trying to find the moment of inertia about the x-axis, we would want to determine the distance to the from the x-axis up to the centroid of each of our shapes. Alright, so those are two steps. Alright, so we divide into simple shapes, and the second thing we would do is we would find the distance to the centroid from the axis of interest. Alright, so once you have that, then you would use the parallel axis theorem to find the moment of inertia for each area. So just to recall, the parallel axis theorem states that the moment of inertia would be equal to the moment of inertia about any axis is equal to the moment of inertia about the centroidal axis of the shape plus the area of the shape times the distance that shape is from the axis of reference. Okay, so in order to calculate I and A, we can use the table on the following page. Alright, so if we go to the next page here, alright, what you'll see is for a bunch of different types of areas, so trapezoids, parabolas, x parabolas. We have a bunch of different. We have the area moment of inertia for a bunch of the different types of shapes. So we have it for quarter circles, quarter sectors, semicircles, circles, rectangles, and triangles. All right, so you can use these to calculate the moment of inertia about the centroid. So once you do that, the last thing you have to do is you have to sum up the individual moment of inertias to determine the composite area. So you would use this formula where the total moment of inertia would be equal to the sum of the moment of inertia for each section, which we describe with, so this is the moment of inertia for the individual section, and then n would be equal to the number of sections. All right. So if you have a hole like we have in our section here, we would have to account for that by, instead of adding it to our moment of inertia, we would have to subtract it. So what we would do here is, let's say that our triangle we'll define as section 1, our square we would define as section 2, and our rectangle we describe as section 3. We could calculate the moment of inertia about the x-axis for each of these. Alright, so what we would say in this case is that the total moment of inertia about the x-axis would be equal to I1 Ix1 plus Ix2, and then since the third is a hole, or it has no, we could treat it as a negative moment of inertia, so we would subtract Ix3 from this problem. Right? So that would be how we would calculate the moment of inertia about this composite shape. All right, we're going to do an example problem of how to do this. All right, so that concludes the method for calculating the second moment of area for a composite section.